Okay, this is going to be another big minus little problem, where we're finding areas, big minus little. We're trying to find the shaded area, so we're going to find the area of a square minus the area of one semicircle. It's supposed to be a semicircle that I'm drawing there, minus the area of the second semicircle. These are the same. So we just got to find that once, and then we can multiply it by 2. So the area of the square, pretty straightforward here. We know area of a square is base times height, which also equals side squared. And we are given that side of 4. So we know the area of the square is 16. The area of this quarter circle is, first of all, we can think of it as a full circle, and we're trying to find this area here. Well, the area of a full circle would be pi r squared, and we can see that the radius is here given as 2, so the area of a full one would be pi times 2 squared, which is 4 pi, but to get a quarter of it we need to multiply this by 1/4 to get just pi. So this region here is pi square units, and then we have 2 of them, so this area is pi square units. So to get, if we come back up to here, the area of the shaded region is going to be the area of the square of 16 minus 2 times the area of this quarter circle. So that is 16 minus 2 pi centimeter squareds. So here we have a equilateral triangle. We know that the radius of that triangle is 6, and we have this circle inside that we're trying to get rid of, or try to get this to subtract away from that. So first order business here is to find the area of this triangle. This is very similar to a problem previously in the review packet, actually, that part of it anyway. We know that this is 6. We have this triangle that's shown in there. This is going to be a 30, 60, 90 triangle. And this side will be 30, and this will be 60. And so we can find the area of this triangle that I'm just drawn right here, this kind of shaded one here. This dashed line, which is the same as this dashed line right here, is going to be 3, because the leg across from 30 degrees is always half the hypotenuse. And so I'm going to go ahead and just draw that in right here, because that's going to help us with the area of the circle. And then this part right here is going to be 3 times root 3. And 2 of those across is going to be 3 root 3. And then so all the way across here is 6 root 3. So if I draw this in here, that's also going to be 6. And so what I'm going to do here is find the area of this triangle, and then take 3 of those to get the area of the full equilateral triangle. So the area of this mini triangle is 1/2 times the base, 6 root 3, times the height, which is 3. And then to get the area of the full triangle, we're going to multiply that by 3, but I guess here we'll do this first. So 6 times 3 is 18. 18 divided by 2 is 9. So 9 root 3 is one of these. We have to multiply that by 3 to get the entire triangle, because there's 3 of them. And so 9 times 3 is 27. So that's 27 root 3. And that will give us the area of the entire equilateral triangle. And then the area of the circle, we can see that the radius is 3, so now that's a pretty straightforward problem. Pi times 3 squared is 9 pi. So the area of the shaded region is going to be the area of the entire equilateral triangle, 27 root 3, minus the area of the circle, which is 9 pi. And that will be units squared. So for 96, somewhat involved here, trying to find the area and perimeter of each of the figures. So for this first one, this is really just an exercise in chunking it up into different rectangles here. So to find the area, you can just find the area of all these little pieces. So this one here, 6 times 2 is 12. I'm just writing the areas inside. 8 times 5, this base times height is 40. This one here, this 5 carries over to here, so 5 times 3 is 15. 2 times, looks like this one is 6. 2 times 6 is 12. This bottom one, we have to do a little work here. This is 3 plus 6 plus 4. So this bottom is 13. Again, the way I found that is 3 up to here, plus 6 gets you to 9, plus this 4 gets you to 13. So 13 times 3 is 39. And then we have this guy here, which is 5 by 6, which is 30. So if we add all those numbers inside up, we should get the area. 15 plus 12 plus 30 plus 40 plus 12 plus 39. That equals 148, and that matches the answer key. The perimeter, then we just have to go around and add up all these pieces here. So 13 plus this 3 plus this 4 plus this 2 plus this 8 plus this 5 plus this 8 plus 2 plus 6 plus this 2 plus this 3 plus this 5 plus this 3 plus this 2 plus this 3 plus this 3. And I started with the 13. If you add all those up, you'll get 72. So just pretend like you're a car driving around and you're keeping track of all the miles. Alright, so 96B, whoa, what happened there? 96B, we have the area is essentially the area of a square plus the area of a half circle. So the area of this square is pretty straightforward. Looks like 6 on a side, so that's going to be 6 squared, or 36. The area, that's supposed to be the square, the area of the circle. Here we know the diameter is 6, so the radius will be 3. And so the area of the circle will be pi times 3 squared, but this is just a semicircle, so we have to take half. So 3 squared is 9, this is 9 pi over 9 halves pi, and so the area will be the sum of those. Add those together because we're adding 2 pieces. 36 plus 9 halves pi. Or it shows 9 pi over 2 units in the answer key, which is fine. Okay, and then so that's the area part. For the perimeter, well, the square part's pretty straightforward. We don't count this part here because we're trying to just go around the outside. So we have 6 plus 6 plus 6. So the perimeter is going to definitely be 18. And then we have half of a circle. So we need to take the circumference of an entire circle, which is 2 pi r, but then only take half of it. And so 1/2 of 2 pi r will just be pi r. So that's going to be 18 plus pi r. We know r is 3. So 18 plus 3 pi will be the perimeter. So that's the area there. That's the perimeter. Just trying to make this more obvious here. And then the last problem is C. We have some circles here. So there are 2 semicircles capped onto a rectangle. We're going to need this base here. One quick way to see it is remember 8, 15, 17 is a Pythagorean triple. If not, you could always find that by doing b squared equals 17 squared minus 8 squared. I'm not going to show the full math there, but that's how you would get 15. Once we've done that, here we know that the radius of this circle is, or semicircle, is going to be 5 because the full diameter here is 8. So the area is going to be the area of this rectangle, which is base times height, which is 15 times 8, which is 120. And then we have the area of 2 half circles. One of those half circles is, well, it's going to be pi times r squared. That would be the whole circle. And the semicircle is half, but then there's 2 of them, so I'm going to multiply that by 2. You also could have seen this as, if I just took this one and redrew it over here, you might see it as the area of one whole circle, which is also fine, but I'm just trying to show it as 2 pieces. So this part here is the half circle times 2, because there's 2 of them. And that's going to be 16 pi. So the area is 120 plus 16 pi units squared. Then the perimeter, well, for the rectangle part, this part is going to be part of the perimeter, this part is going to be part of the perimeter, so it's just going to be 15 plus 15, so it's going to be 30, plus we have 1/2 circumference of a circle plus another half of a circumference of a circle. So circumference of a circle is 2 pi r. We're only using half of it though, so I'm going to multiply it by a half. But then we have 2 of those, so I'm going to multiply it again by 2. And you can see those cancel out, and so we're going to get 30 plus 2 pi r. We know r is 4, so I'm going to put 4 into there, and then we get 30 plus 8 pi units as the final